Our assignment topic is real-time PPE detection system on edge device. We have three group members, which is Yo Kyung Jae, Ivan Yo Jung Xiang, and me, Tan Jik Sing. And now I'm going to talk about the introduction for regarding this assignment. And personal protective equipment (PPE) non-compliance is a primary causes of construction injuries globally. The traditional enforcement strategies such as periodic walkarounds and are labor intensive, inconsistent, and fail to provide continuous coverage. And we are proposing a computer vision solution that offers a scalable, objective, and continuous solution. By developing a camera-based detection system, every worker can be assessed for PPE compliance in real time. And now I'm going to talk about our objective. So for the first objective is to develop a real-time PPE detection system using a fine-tuned YOLO V8N model. And our second objective is detect 14 object classes including critical violation pairs. This we will be discussing afterwards. And our top objective is optimize for edge deployment using INT8 Onyx quantization to drastically reduce model size while maintaining the speed. And our last objective is to create a publicly accessible web application to auto-generated structure safety compliance report.
So let's talk about the methodology pipeline of the system. Step 1, we are going to talk about the dataset and the model use. So the dataset is obtained from the public dataset from RoboFlow, which contains 44,000 images across 14 classes as we mentioned. And the model we use is the YOLO V8N used for the anchor-free detector. And step 2, we are talking about the data augmentation during model training. The ultralytic pipeline require the mosaic composition and the horizontal flips for the image to increase the variability and robustness. Step 3, the image is resized to 640 times 640 pixels during training and reduced to 320 times 320 pixels for edge deployment to strike an optimum balance between inference latency and accuracy. And the step 4 is the post-processing. We deployed the live inference model using OpenCV for pre- and post-processing, applying non-maximum suppression to filter overlaps, and drawing annotation via a gradual web app application. And the 14 dataset mentioned in the project is divided into 4 categories. First, the critical category is about the hard hat, safety vest, and the violation no hard hat, no safety vest. Second is about the warning class, is the glove, goggles, mask, and the violation no gloves, no goggles, no mask. And additionally is the emergency class about the fall detection. And the fourth class is the neutral class about the person detected, ladder detected, and the safety cone detected.
The outcome of our assignment is we have successfully developed a system that can detect comprehensive 14 class of detections. Includes helmet, vest, fall detection, goggles, gloves, and some safety hazard. Other than that, our model can be developed in edge devices. This is much convenient as we can use our phone, our computer, even Raspberry Pi to deploy our GUI, like to use the whole system. Lastly, it is a public accessible web app that we integrated into Gradual Web. So it's very convenient and easy, user-friendly to be used. So as the result of our model, we successfully gained 0.776 of map score on 48 FPS in CPU. So for Onyx model, we successfully quantized the whole model into 3.2 MB because we are using edge devices, so we try to make it as low computational power as possible to prevent any lag or inaccessible problem. For the backup model, we develop a RoboFlow model to back up our Onyx model as to prevent any crash or any scenario. So as the conclusion, a lightweight anchor-free object detector using YOLO V8 combined with large class balance dataset are viable for real-time construction safety monitoring is developed in this assignment and successfully being used in computers, mobile phone and other edge devices.
Okay, in our demonstration, I will be showing the gradual interface of our real-time PPE detection system. And actually, in this GUI, we are split into image upload and live camera functions, which is two functions, which is you can use image upload ways to detect. So I will input the example image and I run the detection. So what you can see, it is a hard hat and safety vest is detected. And here's the bounding box and showing the confidence and the classification type of the hard hat and the safety vest. So now I'm going to input a image of without hard hat and without the safety vest to test the model functionality. And when I run the detection using Onyx model, and what you can see, the hard hat that's caused a violation and the safety vest also caused a violation. This is because there is no hard hat and the safety vest is detected on the person. So it will be considered as the most critical classes that will trigger the warning.
This is the live demonstration of our projects using Gradio GUI. So first we click the access to camera and switch to the front camera. And we started with without any PPE detection, just a normal human detection, see whether the result is accurate or not. So we can see that there's a warning, an alert shown from the result, no hard hat and no safety vest, which is the two critical component is missing in the picture or video that we present. Okay, so now this is the demonstration with PPE, with helmet and safety vest. Why this is flickering? Because we are using 48 FPS for the video demonstration, so it will show some flickering and
On the GUI. And the hard hat and the safety vest is the most critical component in the PPE, whether it is in construction or in medical field or in production line. But currently we are showing the example of construction places PPE.